Hi, I'm Ed Celebril from Math 2A. Our topic is under the topic in Lesson 2, Properties of Matrix Operation, which is Theorem 2.4, Properties of Identity Matrix. If A is a matrix of size m by n, then the following are true. A multiplied by n subscript n is equal to A. Number 2, n sub or L subscript or n multiplied by A is equal to A. First, for our first property, A, we have a given value of A which is 3, negative 2, 4, 0, negative 1, and 1. And the other is 1, 0, and 0, and 1. By multiplying these two matrices, we get a value of 3, negative 2, 4, 0, negative 1, 1. As like what you observe, by multiplying these two matrices, we get a value of this, just like a value of matrix A. They are both same. So we can say that A multiplied by L subscript n is equal to A. For our second theorem or second property in under the theorem 2.4, L subscript n multiplied by A is equal to A. We have a given value for this 1, 0, 0, 0, 1, 0, 0, 0, 1. Matrix A, 2, 1, and 4. By multiplying these two matrix, we get a value of negative 2, 1, and 4. Just like what you observe, they are the same in value of matrix A. So we can say that L subscript n multiplied by A is equal to A. That is our theorem 2.4, which is properties of identity matrix. For the next theorem, theorem 2.6, properties of transpose. If A and B are matrices and C is scalar, then the following are true. A transpose, that's called transpose of a transpose. A plus B transpose equal to A transpose plus B transpose, or transpose of a sum. Scalar A multiplied by A transpose is equal to C, or scalar C multiplied by A transpose, which is called transpose of scalar multiple. For the last property, quantity A or matrix A multiplied by matrix B transpose is equal to B transpose A transpose, or transpose of a product. So we go to first property, which is transpose of a transpose. We have a given value of A, 3, 1, 2, and 6. In transpose, you can write the column into a row. Write this column into a row. So in this 3, 1, 2, 6, we have a transpose of 3, 2, and 1, 6. We can write this column into a row. So when you transpose this A transpose, will you go back to the value of A? A transpose, write this column into a row, write this column into a row, 3, 1, and 2, 6. So A transpose is equal to the value of A. That's our first property in theorem 2.6. For the second, transpose of a sum. We need to prove that quantity A plus B transpose is equal to A transpose plus B transpose. We have a given value of A 5, 1 and 4, 8. Value of B 3, 6 and 2, 4. A plus B is simply additive or add corresponding elements. 5 plus 3 is equal to 8. 1 plus 6 is equal to 7. 4 plus 2 is equal to 6. 8 plus 4 is equal to 12. So we have a value of A plus B, but we need a value of A plus B transpose. So for this matrix, we write this column into a row to get A plus B transpose. So we have 8, 6, 7, and 12. So we have a value of A plus B transpose. For A transpose plus B transpose, we have a value of A 5, 1 and 4, 8, 3 for the matrix B 3, 6 and 2, 4. We need to get the A transpose. Write this column into a row. 5, 4, 1, 8. Write this column into a row. 3, 2, 6, 4. So we have a value of A transpose and B transpose. Then add these two matrices. A transpose plus B transpose. So we get a value of 8, 6, 7, and 12. So we can say that the value of quantity A plus B transpose is equal to the value of A transpose plus B transpose. They are both the same. That's our number or properties number 2. We go to properties number 3 under the theorem 2.6, or the transpose of scalar multiple. Scalar C multiplied by matrix A transpose, we need to prove that they are the same in scalar C quantity A transpose. Scalar C, which is 4, and matrix A is equal to 1 and 6. So we need to multiply these two. 4, or the value of C or scalar C, multiplied by the matrix A. 4 multiplied by 1 is equal to 4. 4 multiplied by 6 is equal to 24. And then transpose. Write column into a row. 4 and 24. 4 and 24. The value of scalar C multiplied by matrix A transpose is 4 and 24. For the value of matrix C multiplied by A transpose is equal to scalar C. The value of scalar C is 4, and A transpose, the transpose of matrix A, is 1 and 6. So we get a value of 4 multiplied by 1 is 4. 4 multiplied by 6 is 24. Just like what you observe, the value of C or scalar C multiplied by matrix A transpose is equal to the value of C or scalar C multiplied by A transpose. So we can say that they are the same. That's our third property under the theorem 2.6, which is properties of transpose. Or number 3, property transpose of scalar multiple. For our last theorem, transpose of a product, we need to prove that quantity A multiplied by B transpose is equal to B transpose multiplied by A transpose. We have a given value of A or matrix A 3, 1, 6, 2, matrix B 2, 7, 3, 4. So first multiply matrix A to matrix B. By multiplying these two matrices, we need a value of 9, 25, 18, and 50. So we need to transpose it to get what we were, just like that. Write this column into a row, 9, 18, 25, and 50. So we get a value of multiplying matrix A to matrix B transpose. For the second equation, or B transpose equal to A transpose, the value of A is 3162. The value of matrix B 2734. So we need to get A transpose. Writing this column into a row, 3, 6, and 1, 2. 2, 3, and 7, 4 for B transpose. So we need to multiply these two matrices, B transpose, the value of B transpose, and the value of A transpose. By multiplying these two matrices, we have a value of 9, 18, 25, and 50. So for the value of quantity AB transpose, 9, 18, 25, and 50, just like the same, the value of B transpose multiplied by A transpose. So we can say that quantity AB transpose is equal to B transpose A transpose. That is our fourth theorem, or last theorem, or last property under the theorem 2.6, or properties of transpose. Thank you.